After studying the concept of what is an algorithm, the next topic we are going to discuss here is fundamentals of algorithmic problem solving. So here there is a sequence of steps one typically goes through in designing and analyzing an algorithm. So these are the steps which one should follow when designing an algorithm for a given problem. So the first step here is understanding the problem. So from a practical perspective, the very first thing you need to do before designing an algorithm is to understand it completely the problem given. So how we can understand the problem means, so we have to read the problem's description carefully and ask questions if you have any doubts about the problem, and do a few small examples by hand and think about the special cases and ask the questions again if needed. So this is a repeated process, so you will get to know the clarification about the given problem. So there are few types of problems are there that arise in computing application quite often. So if the problem in question is one of them, so which is arising very quite often, so you might be able to use a known algorithm for solving it. Of course, it helps to understand how such an algorithm works and to know its strengths and weakness. Especially, you have to choose among several available algorithms. But often you will not find a readily available algorithm for a given problem, and will have to design a new algorithm by your own. At this time, the sequence of steps outlined here will help you in this exciting but not always an easy task. So algorithm writing is not an easy task. So sometimes the algorithm for some of the problems may be readily available, but that is not the case for all the problems. So an input to an algorithm specifies an instance of the problem the algorithm solves. So it is very important to specify exactly the set of instances the algorithm needs to handle. If you fail to do so, your algorithm may work correctly for a majority of inputs but crash on some boundary value. So you may remember that. So when I explained the concept of algorithm, so we have to precisely mention the input, on what input our algorithm is works and for what input our algorithm is not bothering about. So this is what the thing. So we have to precisely mention only for what inputs our algorithm will work. And remember very one thing, so the correct algorithm is not one that works most of the time, but it is the one that correctly works for all legitimate inputs. So if the given input value is a legitimate input, so that whenever you design an algorithm, that algorithm should work properly for all the legitimate inputs. So if anyone want to skip this first step of the algorithmic problem solving process, so you will run into a risk of unnecessary rework. So that is why don't skip this first step, that is understanding the problem. So then coming to the next step, so we have to decide between some of the options available here. So the first thing what we need to decide is ascertaining the capabilities of the computational device. That is, the computational means what I have written here. So that is the computational device, on which device we are running our algorithm. So that is the next thing what we have to decide on. So once understanding the problem step has been completed, the next step you need to do is to ascertain the capabilities of the computational device the algorithm is intended for. So the vast majority of algorithms in use today are still destined to be programmed for a computer that is closely resembling the von Neumann machine. So everybody know that what is this von Neumann machine is. So it is a computer architecture outlined by a prominent Hungarian American mathematician John von Neumann. So the essence of the architecture is captured by so-called random access machine. So, its central assumption is that instructions are executed one after the another, one operation at a time. So, accordingly, the algorithm designed to be executed on such machines are called sequential algorithms. So, when you ascertaining the capabilities of the device on which your algorithm is running, so whether you have to decide that your algorithm is working on a sequential algorithm or the algorithm which you are running is a parallel algorithm. Parallel algorithm means at a time two or more things task will be running at a time, but sequential means so that is the algorithm which will be executed one after the another steps in a sequence and one step at a time. So the central assumption of the RAM model does not hold for some newer computers that can execute the operations concurrently, that is in parallel. So the algorithms that take advantage of this capabilities, to those algorithms what we call it as in parallel algorithms. So still, studying the classic techniques for design and analysis of algorithms, that is under the RAM model, that is the algorithms are sequential algorithms. So there remains the cornerstone of algorithms for the foreseen future also. So should we worry about the speed and amount of the memory of a computer at your disposal? So, if you are designing an algorithm as a scientific exercise, the answer is qualified no. So, most of the computer scientists prefer to study the algorithms in terms of independent of specification parameters for a particular computer. So, if you are designing an algorithm as a practical tool, the answer may depend on the problem you are going to solve. Even today, the slow computers are almost unimaginably fast. So, because you are running the algorithm converted to a program in a computer system, so you no need to bother about the computational device whichever you are using, whether it is a old system, whether it is a slow system, you no need to bother about those things, just write the algorithm. But one thing you can keep in the mind that there are two types of algorithms you can write. One is a sequential algorithm or your algorithm may be a parallel algorithm, but nowadays you can go for the parallel algorithm which runs very faster one. So this is not a much important phase. So when you try to find the computational device means, so then coming to the next thing, that is exact versus approximate solving. So we have to choose between exact and approximate problem solving. So what is this is, so the next principal decision we have to choose, that is whether the problem you are going to solve, you're solving it approximately or you're going to get the exact values. So if your algorithm is going to give the exact value, so we call that algorithm as exact algorithm. Otherwise, if you're getting an approximate value, your algorithm is called approximation algorithm. So why we need to opt for an approximation algorithm? So why we need to choose between exact and approximation algorithm is very first thing. So there is an important problems that simply cannot be solved exactly for most of their instances. For example, if you are extracting square roots, solving a nonlinear equations and evaluating a definite integrals, So you cannot get the values that is a clearly a exact one. And the second one is available algorithms for solving a problem exactly can be unacceptably slow because of the problem's intrinsic complexity. So this happens in particular for many problems that is involving a very large number of choices. So the third thing is an approximation algorithm can be a part of a more sophisticated algorithm that solves a problem exactly. So if your algorithm is solving a problem in an approximate value, that is what the resulting is, so you no need to bother much about that one. So no need to bother about only in getting the exact values. Even sometimes we need to get the approximate values, and that is not a big issue. So then coming to the next one, that is the algorithm design technique. So this is a very important thing. So now we have to choose an algorithm design technique. So then what is an algorithm design technique is? So an algorithm design technique or a strategy is a general approach to solving problems algorithmically that is applicable to a variety of problems from different areas of computing. So when we move to the next chapters, so we will get to know what is an algorithm design technique is, because all the chapters we are going to study that is based on a algorithm design technique, and the problems we are going to study there are very different kinds of problems, because the in a single algorithm design technique the problems or the algorithms written, they are not the same. There are very different kind of problems will be there, but there is a algorithm design technique which we are going to solve using the given technique. So what is this importance of this algorithm design technique is means, so they provide you the guidance for designing algorithms for new problems, that is the problems for which there is no satisfactory algorithms. So therefore, to use the language of a famous proverb, learning such technique is akin to learning to fish as opposed to being given a fish caught by somebody else. So what it means is, so there are many algorithm design techniques are available. So when you are writing a new algorithm, what you can do is you have to master in the algorithm design techniques, so that you can apply any one of the technique to solve the problem given you by writing a new algorithm. Suppose your problem is having several algorithms already, so for the same problem you can apply a different algorithm design technique, so that you can write a new algorithm for the existing problem also. So this is what the main thing about the algorithm design technique, that is you need to choose among many of the available algorithm design techniques. So after you decide an algorithm design technique, so that is a very powerful set of general approach to algorithmic problem solving. So the next step is designing an algorithm. So it is very challenging task, and some design techniques can be simply inapplicable to the problem in question. So sometimes several techniques needs to be combined, and there are algorithms that are hard to pinpoint as applications to the known design technique. Even when a particular design technique is applicable, getting an algorithm often requires a non-trivial ingenuity of the part of the algorithm designer. So that, so you have to design an algorithm that is based on any of the algorithm design technique. So when you designing an algorithm design technique, you are designing an algorithm, you have to choose an data structure. So choosing a data structure that will be appropriate for your operations that is performed by the algorithm. So many years ago, there is one influential textbook which proclaimed the fundamental importance of both algorithms and data structure for computer programming by its title, algorithms plus data structures is equals to program. So this just line implicates, so what is the importance of data structures in writing a program that is with the algorithm. So you need to choose an appropriate algorithm design technique, then appropriate data structures to design your algorithm. So then after this we will study methods of specifying an algorithm. So this step is not here, but we need to study how we are going to represent an algorithm. So we can represent the algorithm using natural language. So natural language, for example, we can make use of English language and we can represent our algorithm. As you can see in the last concept, when we have explained what is an algorithm, the Euclid's algorithm that has been completely written in the English language, so that is also an algorithm. So using any natural language you can write your algorithm or you can represent your algorithm. So apart from this, the another method is pseudocode, and that is a mixture of a natural language and programming language like constructs. So that is also you have seen in the previous examples. So the pseudocode is usually more precise than the natural language. So why? Because anyhow, when we write an algorithm, the next thing we are going to do is we are converting that algorithm to a program. So in between, when we represent an algorithm, when we make use of the programming like construct, it is easy to transform from an algorithm to a program. So that is why, so we are making use of the programming language like construct. And the pseudocode is usually more precise than the natural language, and its usage often yields more good algorithm descriptions. So in the last example, as we have seen, we have used while loop, or we may use the for loops like this, if statement, while statement, this kind of programming structures, so programming constructs we can make use in our representation of an algorithm. That is what we call it as a pseudocode. And the another method in from which we can represent our algorithm is, so we can represent it using a flowchart. And this flowchart is a method of expressing an algorithm by a collection of connected geometric shapes, that is containing the descriptions of the algorithm steps. This representation technique has proved to be inconvenient for all but very simple algorithms. But what is the main disadvantage of this flowchart is, if the algorithm is lengthy, so you cannot represent your algorithm that is using a flowcharts. So if your algorithm is very small, so it is convenient to represent the algorithm using flowchart. But among natural languages, pseudocode and the flowchart, so pseudocode representation is the good for representing an algorithm. Then after designing an algorithm and we have represented it, so the next step is to prove the correctness. So once the algorithm has been specified, we will prove its correctness. So that is, you have to prove that the algorithm yields a required result for every legitimate input in a finite amount of time. And this is what the definition of an algorithm is, it right? So for example, so we have already know what is an Euclid's algorithm is. So how we are going to prove that the Euclid's algorithm is correct for computing the greatest common divisor? So there the correctness of the equality comes, that is GCD of m comma n is equals to GCD of n comma m mod n. So the simple observation that the second integer gets smaller on every iteration of the algorithm, and at some point the algorithm stops when the second integer becomes 0. So this is what proves the correctness of the Euclid's algorithm, and we know that it yields a correct value. But for some algorithms, the proof of correctness is quite easy, and for others, it may be quite complex. So, the common technique for proving correctness is to use mathematical induction. So, this is one of the method from which we can prove the algorithm's correctness, because an algorithm's iteration provides a natural sequence of steps needed for such proofs. And it might be worth mentioning that although tracing an algorithm's performance for a few specific inputs for may be very worthful, and you cannot prove the algorithm's correctness by just writing some of the problems and solving it. So that is why we have to prove the algorithm using any of the methods like mathematical induction. Then the next step is to analyze your algorithm. After writing an algorithm and proving its correctness, so the next step is to analyze an algorithm, because so there are many algorithms available for a single problem, and that we know already very well. So that is why analyze an algorithm and prove that your algorithm is best among all the algorithms available already. So after correctness, so the very important thing is efficiency. That is what we call it as an analysis of an algorithm, that is to find its efficiency. And there are two types of efficiencies, that is time efficiency, that indicates how fast the algorithm works, and the space efficiency, that indicates how much extra memory it uses. So another very desirable characteristic of an algorithm is simplicity. So that means that your algorithms should be simple, so that when you trace your algorithm just using a pen and a paper, it should be easy to trace your algorithm, and it should be, when you look at the algorithm, that it should be a simple one like the Euclid's algorithm. Okay, so that is what the another quality your algorithm should possess. And then the next step is to code the algorithm, and this efficiency of an algorithm we are going to study in detail in the next classes. So that is why only the definition of efficiencies are enough. So then coding an algorithm, that is, most of the algorithms are destined to be ultimately implemented as computer programs, and we know that a programming an algorithm presents both a peril and the opportunity. So the peril lies in the possibility of making the transition from an algorithm to a program either incorrectly or very inefficiently. But some influential computer scientists strongly believe that unless the correctness of a computer program is proven with full mathematical rigor, the program cannot be considered correct. They have developed special techniques for doing such with the proof, but the most power of these techniques of formal verification is limited so far for very small programs. So there are very important concepts. So by a practical matter, the validity of a program is still established by testing. Testing of a computer program is an art, and using that program testing, we can prove the correctness of the program, that which we have translated from an algorithm to a code. So these are the steps in which, so we are going to study about fundamentals of algorithmic problem solving. So we have to follow these steps one by one after the another, and you can see the arrow marks here. So that is, so when, if the algorithm is, you are not supposed to proving the correctness of the algorithm, so you can go back and you can make some of the changes, that may be exact versus approximate algorithm or algorithm design technique, and you can make changes to the design of an algorithm. And when you are analyzing an algorithm, and you can go back and you can make some of the changes, that is from the beginning, but you cannot go to the understanding the problem step. So that is why understand the problem properly, and based on that one you can make some of the choices available based on that one. So the data structures, the algorithm design technique, so you can design a very new algorithm for the given problem, and you have to follow all these steps. So here, so in the next concept, we are going to study how to analyze an algorithm. Because so when we study an algorithm, so the analyzing of an algorithm is very important task. That is why the subject itself tells its name as analysis and design of algorithms. So when we study an algorithm, its analysis part is very important. So in the next class, in the next concept which we are going to study is that is based on how to analyze an algorithm. So after getting the general idea of how to analyze an algorithm, so then we can start studying different algorithms, that is based on different algorithm design technique.